Hello students, in today's lecture, we will try to solve maximum number of numericals on Poynting theorem, which is telling us about the energy in an electromagnetic field. So first, quickly let us see what all formulas we will be using to solve the numericals related to Poynting theorem or Poynting vector S is equal to E cross H. Let us begin. See, now since Poynting theorem is related to electric field component and magnetic field component, so the maximum electric field in the plane electromagnetic wave is related to the maximum value of magnetic field by the formula E is equal to C into B, where C is velocity of light. Its mathematical value is 3 into 10 to the power of 8 meter per second. Now, remember one thing, E or B, that is E is the intensity or strength of the electric field and B is the intensity or strength of magnetic field. Since it is moving in an as a transverse wave, E naught E equal to E naught exponential to the power of I omega t minus kx, where omega is angular frequency, t is time, k is your wave factor, and x is the displacement. Here E naught is amplitude of the field and E is intensity or strength. Another term, root mean square value, is given by E naught upon root 2. Now, the amplitudes of electric and magnetic fields of radiation are equal to E naught is equal to E into root 2, H naught is equal to H into root 2. Now, the maximum electric field, okay, then average electric energy density is given by 1 upon epsilon naught E naught square, and average magnetic field is given by half mu naught H naught square. Power radiated by surface area of a sun. Since sun is spherical in shape, we will take the area as 4 pi r square. So power is equal to S, which is Poynting vector, into 4 pi r square, where r is radius of the sun. Then we have few more formulas. S, which is Poynting vector, is equal to 1 upon mu naught into E cross B. Mu naught is permeability, which is 4 pi into 10 to the power of minus 7 Weber per ampere meter. B, the magnetic field strength, is equal to mu naught into H, and S is equal to E cross H, and E upon H is equal to under root mu naught upon epsilon naught, which is approximately 377 ohm or 376.4 ohm. Root mean square is E naught upon 2. Few constants which you should be knowing also. Let us begin. The very common question which is asked in Poynting theorem is, a 100-watt sodium lamp is radiating its power. Calculate the electric and magnetic field strengths at the distance of 5 meters from the lamp. Now see, here the units you don't need to convert. You have been given it in watt. This distance 5 meters will become radius. So the entire energy which is radiated by the lamp uniformly, and the lamp is acting as a point source of energy. So the total energy flux over a sphere of radius 5 meters drawn round the lamp as center is given to you as 100 watt. Area of a circle sphere is 4 pi r square. So that becomes area. Flux per unit area per second is equal to power upon area. You simply put the values. You have got your value for Poynting vector, and from Poynting theorem, S is equal to E cross H. E and H are perpendicular to each other. Their angle between them will be 90 degrees. So S straight away becomes EH. So your mathematical value of S is 3.18 and E upon H ratio is equal to 377. Simply solve these two equations, E dot H and E upon H. Cross multiply them, you get your individual values which you are required to find for electric and magnetic field. On the very similar pattern, you have another question. All Poynting numericals consist of total energy and they expecting you to find electric field and magnetic field. See, the numerical is exactly similar to what we did right now, but here they are asking you to find out the average values of the intensities of electric and magnetic fields at a distance of 2 meters from the lamp. Same process will go. S is equal to P upon A. That is, here it is given 1000 watt. R, distance of 2 meters from the lamp. From Poynting theorem, EH and E upon H. Two simultaneous equations, EH and E upon H. Either you cross multiply them or divide them to find out the individual values of E and H. Now, look at this numerical. Here, if Earth receives 2 calorie per minute centimeter square solar energy, what are the amplitudes of E and H? Here in the numerical, you will first have to convert these units into a uniform fashion. That means either you do them into CGS or MKS. That is the only trick in the numerical. See, energy transported is S is equal to E cross H. And that is EH because E and H are perpendicular to each other. Now have a closer look at S. 2 calorie per minute per centimeter square. Let us change the units. 1 minute is 60 seconds. 100 centimeter is 1 meter and 1 calorie is approximately 4.2 joules. So calorie will be changed to joule. Minute will be changed to seconds and centimeter will be changed to meter. 100 centimeter is 1 meter. After changing all units, you normalize them. Then EH is this much and E upon H is a standard 377. Either cross multiply or divide and you get your individual values here. And if they are asking you to get the amplitude, E naught is equal to E into root 2. That is the amplitude. That means it is the peak. When a wave travels, it has an amplitude. Find the magnitude of Poynting vector at the surface of sun. You have been given power and radius of the sun. Once again, power radiated by surface area 4 pi r square of the sun is P equal to S into 4 pi r square, right? So P has been given to me as this much, R is this much. I put the values and what I will do is, see, I can see 10 to the power of 28 here and 10 to the power of 16. 8 twos are 16. I will get all these units this side and 10 to the power of 28 minus 10 to the power of 16 and this I will divide and I will get my answer. 10 to the power has to be solved here. The electric field in an electromagnetic wave is given by this value. You have to find the energy which is contained in the cylinder of cross section 10 to the power of minus 3 meter square and length 100 centimeter. Average electric energy density is 1 upon 2 epsilon naught E naught square. If V is volume of cylinder, then energy contained in this volume is half epsilon naught E naught square into V, where V is area into length, that is volume, formula of volume. Length is 100 centimeter, change it into meters. And then your volume becomes here, cross-sectional area into length. Put these values in the formula up. Epsilon naught is 8.85 into 10 to the power of minus 12. E naught is 100, it is given, and this you have changed 10 to the power of minus 3. And then you take 10 powers here, minus 12 plus 4 minus 3, you solve them, and 2 divided 8.85 divided by 2 becomes 4.425, and then the 10 powers, you can write the answer like this. If the upper atmospheric layer of Earth is receiving so much energy from sun, what will be the peak value of E and B? See, energy flux S is equal to E cross B upon mu naught. E upon B is equal to C, velocity of light. So instead of B, we can write E upon C from this formula. So this formula becomes S is equal to E square upon mu naught C. And for the root mean square value, root mean square upon mu naught C. From definition, root mean square is equal to E naught upon root 2. So your S becomes E naught square upon 2 mu naught C. This 2 comes from square of root 2. And you get E naught is under root 2 mu naught CS. Now just put the mathematical values here. Mu naught is 4 pi into 10 to the power of minus 7. C is 3 into 10 to the power of 8. And S is 1360. These values you have put, it is a square root which you have to take out. Pi is 3.14. 10 powers, we shift them to one side. Rest, we multiply the quantities. And then for peak value of magnetic field, B naught is equal to E naught upon C. Straight away, and you get the answer. If the average distance between sun and earth is given and the power radiated by sun is this much, find the average solar energy incident on the sun. If R is distance between centers of sun and earth and SE is the Poynting vector at surface of earth, then S is equal to P upon A, or S into A is equal to P. S is Poynting vector here. You straight away put the values that have been given to you in the numerical. You can change them into calories by dividing by 4.2. That is the conversion factor between calorie and joules. A monochromatic plane polarized electromagnetic wave is traveling eastward. The wave is polarized vertically with electric field strength directly alternatively up and down. You have to find E, H, and B and the Poynting vector. Okay, you have been given electric field strength and frequency. How does an electromagnetic wave travel? The electric field components, the magnetic field components getting perpendicular to velocity of light. See, it is polarized in the y direction and the x and z components here are 0. This is what the numerical is telling us. So the magnetic field is along xz axis, that is hx, hy equal to 0. Frequency is 6 megahertz. Change it into hertz, that is 10 to the power of 6. You multiply it by 10 to the power of 6. Time period is 1 upon frequency. That means you get this. Wavelength is equal to C upon frequency. Now, monochromatic plane polarized EMT wave is expressed as EY is equal to E naught sine omega into T minus X by C. Put these values here and straight away what they have given you in the numerical, all the values, you put them. One more formula you can use is H naught upon E naught is equal to under root epsilon naught upon mu naught, or inverse of it. The standard value is 376.72, and you put these values and you get H here. This is what has been asked in the numerical. Thank you.